All right, let's talk about one of the coolest, most powerful ideas in all of computing. It's called virtualization. And really, it's the magic trick that lets you run a whole, complete, separate computer right inside the computer that's already sitting on your desk. So how on earth is that even possible? Well, let's dive in.
Okay, let's make this super real for a second. Have you ever been using your Windows PC and thought, man, I'd love to try out Linux, but you really didn't want to go through the whole nightmare of wiping your machine or buying a brand new one? Well, guess what? Virtualization makes that not just possible, but actually pretty easy.
In fact, you can often get started in just two simple steps. You grab a free tool, it's called a virtual machine manager, and then you load up a pre-made operating system image. It's kind of like popping a game cartridge into an old Nintendo, but instead of a game, you're loading up an entire OS. But that simple process is hiding some really different, really fascinating technology under the hood. So let's look at the two main ways we can build a computer inside your computer.
Okay, path number one. We're going to call this the virtual machine fortress. I want you to picture this as building a complete, totally self-contained, heavily armored digital castle for a brand new operating system to live in, completely walled off from everything else. So think about how your computer normally works, right? It seems pretty straightforward. You've got your physical hardware, your CPU, your memory, all that good stuff, and then you have the operating system which talks directly to it. But what if we could just slip something new right in between them? A new layer, a kind of manager that sits in the middle and controls everything. And that is exactly what this first path does. This new middle manager, it has a fancy name, a hypervisor. And as you can see right here, it basically takes command of the real physical hardware, and then it creates these virtual copies for multiple, totally separate guest operating systems to use. Now, the key word here, the most important part, is illusion. See, the hypervisor is a master trickster. It fools each guest operating system into thinking it has its own private computer. The OS thinks it's talking to the real CPU, the real memory, but nope. In reality, the hypervisor is the puppet master pulling all the strings from behind the scenes. And building a fortress like this, well, it comes with some pretty clear pros and cons. On the one hand, you get this incredible bulletproof isolation. If one virtual machine crashes and burns, it doesn't affect anything else, not the other VMs, not your main system. Plus, you can run totally different worlds side by side. Linux on Windows, Windows on a Mac, you name it. But here's the big downside. It's heavy. It's a resource hog. Each fortress needs its own complete copy of an operating system, its own virtual hardware, and that uses up a lot of your computer's power. So that's the fortress. Now let's look at our second path, which takes a completely different, much more lightweight approach. We're going to call this one the fenced yard. Instead of building a whole new castle every time, what if we could just build a small fenced-off area inside the yard we already have?
And this gets to a really fundamental question. The fortress approach virtualizes the actual hardware. But what if we could get that same kind of isolation, but at the software level? What if we could do it just by being really, really clever about how the operating system starts a new program?
And this, right here, is where it gets ingenious. So in an operating system like Linux, the normal way to start a new process is with a command called fork. And what fork does is it makes a complete copy of everything. But there's another way, a command called clone. And clone doesn't copy. Instead, it creates a new process that just points back to the stuff its parent is already using.
I know, pointing instead of copying might sound like a super small, nerdy, technical detail, right? But I promise you, this one tiny shift, it changes everything. It is an absolute game changer, and it's the foundation of a much faster, much more efficient way to do virtualization.
The payoff here is just massive. Because you're not making huge copies of everything, these fenced yard environments can start up almost instantly. This is the technology that we all now know as containers, like Docker. But there is a catch. Since they're all just sharing, they have to share the very core of the host operating system, what's known as the kernel. And that means you can only run containers that speak the same language as the host. You can't, for example, run a true Linux container directly on a Windows kernel. Okay, so you've seen the fortress, and you've seen the fenced yard. Let's put them in the ring right now for a head-to-head showdown to really nail down what makes them so different. This table just lays it all out perfectly. Let's break it down. Over here, you've got the fortress, the virtual machine. It's built on a hypervisor managing the hardware. That gives you complete, total, ironclad isolation. But that power comes at a cost. It's a resource hog, and it's slow to start up. We're talking minutes. Now, look at the fenced yard, the container. It's built on that clever clone system call, sharing the kernel. This makes it ridiculously fast. We're talking seconds or less, and super light on resources. But its isolation is only at the process level, and you give up the flexibility to run any old OS you want. It's that classic battle, total security versus blazing speed. So, all this technical talk about fortresses and fenced yards, why should you care? Well, because this virtual world isn't just some neat trick for developers, it is the engine that powers the entire internet as we know it, from the laptop in front of you to the biggest data centers on the planet.
Seriously, whenever you hear somebody talk about the cloud, what you should really picture is gigantic buildings packed with servers running millions and millions of these virtual fortresses in fenced yards. These two ideas we just talked about, they are the absolute fundamental building blocks of almost every single online service you use every day.
And the impact is just staggering. Think about efficiency. Cloud providers can now pack thousands of those lightweight fenced-yard containers onto a single physical server. That's incredible. Or flexibility. A developer can build an app in a container on their laptop and know for sure it's going to run exactly the same way anywhere else. For stuff that needs to be super secure, like processing your bank transactions, companies still rely on the total isolation of a Fortress VM. And all of this together is what allows the internet to scale up and down in seconds to serve billions of people.
You know, this quote really gets to the soul of what an operating system is supposed to do. Its entire job is to create an environment where other programs can do useful work. And virtualization, whether you're building a massive fortress or a tiny fenced yard, is the ultimate expression of that idea. It's about creating the perfect, custom-made environment for any application whenever you need it. So I'll leave you with this to think about. As our computers keep getting faster and more powerful at this incredible rate, what's next? Are we going to use all that power to build even bigger, more complex fortresses with entire operating systems inside? Or are we going to focus on creating millions upon millions of these hyper-efficient, super-fast fenced yards? The answer to that is going to shape the future of everything we do with computers.